All right, first things first, let's go over the warm-up. So in the warm-up, the first thing you should have done for this problem, or what I would have done, was distribute that 3. You can divide both sides by 3. Don't recommend that because then you're gonna get even nastier fractions on the right side, but to each their own. Now when you distribute the 3, you're gonna get 3 over 2 minus 3y, because remember you're multiplying by both terms, and then the right side stays the same. So it's gonna be 3 over 5 plus 15y. Beautiful. So from here, you've got to recognize, okay, I see both the y's, so let's go ahead and move those to one side. I would add 3y to both sides, and then we're going to get 3 over 2 equals 3 over 5 plus now 18y, okay? And then from here, you want to move the number portions of both the fractions without y in them to the left side, so minus 3 over 5 minus 3 over 5. And we're going to get 3 over 2 minus 3 over 5 equals 18y, because these cancel. Okay, so from here, what I want you to recognize is that we do not have a common denominator. You can easily get one by multiplying this fraction by 5 in the top and the bottom, and the top and the bottom over here by 2. Now watch what happens. 3 times 5 is 15. 2 times 5 gives me 10, minus 3 times 2 gives me 6, and 5 times 2 gives me 10. Now we do have a common denominator. This stays the same as 18y. We haven't touched the right side. And now we can subtract them. 15 minus 6 is going to be 9 over 10, which is equal to 18y. Then we divide by 18, divide by 18. Now remember, we're dealing with fractions, so you can either think about it as keep, change, flip, or you can think about when you divide by a whole number, that's the same as multiplying by the reciprocal, which is 1 over 18. So this is 9 over 10 times 1 over 18, which is equal to y, because these 18s are going to cancel. Now, from here, a lot of students canceled out the 18 and the 9, and they found a common factor of 9. This becomes a 1, and the 18 becomes a 2. So now we have 1 times 1, which is just 1 in the numerator, and 10 times 2, which is just 20 in the denominator. So your answer is 1 over 20. All right, and next, let's go ahead and get started. So today we're talking about the number of solutions for a linear system, okay? So if you look at the graph for the very first example, this is an example. These are the examples we've done in the past 3 lessons where we have exactly one solution. The reason there's one solution is because they intersect exactly once. Okay? And that intersection point, the red dot in this first image, that becomes our solution. So when we were finding a y value, when we were finding an x value, it would coordinate or correspond to the point where the 2 lines intersect, okay? Now, the second graph shows 2 lines that do not and will not ever intersect, okay? They continue on forever. They have the same exact direction, so there's no solution because they are never going to intersect. Never going to intersect. Okay, now we have a name for these kinds of lines, and the name is parallel. So these lines are parallel, and one thing that I want you to know about parallel lines is that they have the same slope, but different y-intercepts, okay? So in y equals mx plus b form, their m's are the same, their slopes are the same, but their y-intercepts are different, okay? So now the last third example, it almost looks like there's exactly one line here, but imagine that there's 2 lines and they're just overlapping, okay? So both the lines are right on top of each other. Now, this is the scenario where the slopes obviously are going to be the same because it's the same line, but the y-intercepts are also going to be the same. These 2 lines are going to cross the y-axis at the exact same point. So the reason why there's infinitely many solutions for this is because they will intersect an infinite number of times. okay? So the lines are exactly the same. All right, let's see examples of no solution and infinitely many, okay? So for these examples, I want us to start getting really good at determining which method to use. So for A, what we're going to do is we can either use substitution or elimination, or we can think about these as graphs, okay? Let's start off by using substitution. Okay, if we use substitution, we can make either one our substitution. I'm going to make the top one my substitution. So now I'm going to take this 2x plus 1, and I'm going to substitute it in for the y in the second equation, okay? So wherever I see y in the second equation, instead I'm going to put 2x plus 1. So we'll start off with y, so I'm going to put 2x plus 1 equals 2x minus 5. Now, once we have this, all we need to do is start to solve. We would subtract 2x from both sides, minus 2x. These are going to cancel, these are going to cancel, and we get 1 equals negative 5. Now, 1 is certainly not the same amount as negative 5, so we would say that this does not work, and there is no solution. Okay? Notice the difference here, guys, is your variables completely go away, and we're left with two numbers separated by an equal sign. If it's a true statement, there would be infinitely many solutions. If it's a false statement like this one, then it's no solution, okay? Now, before even doing this problem, if you just looked at it and at a glance, you notice that the slopes are the same, but the y-intercepts are different. That's an example of parallel lines. Therefore, there is automatically no solution. So there was no use in even doing substitution other than the fact that we're just kind of seeing how we would get to no solution regardless, okay? Let's take a look at B. Now, B is less obvious that there's no solution, okay? So you would just pick any method that you would like. I'm going to pick substitution again because y is already solved for. Now, my substitution now becomes negative x plus 3. I'm going to highlight that. And in my second equation, I'm going to rewrite it, but wherever I see y, I'm going to put negative x plus 3. So we've got 2x plus 2 instead of y. Now I'm plugging in negative x plus 3 equals 4. So once I have this, I've got 2x plus 2 times negative x is negative 2x. 2 times 3 is plus 6 equals 4. Now, 2x plus negative 2x is the same as 2x minus 2x, which they're going to cancel because that's 0. So I get 6 equals 4, which is no solution as well, because 6 is certainly not equal to 4. Okay, awesome. So let's go ahead and go to C. Our very first example, all the way back at the top. Whenever you have the same exact equation, you're going to get the same line when you graph it. And if you have the same line when you graph it, it's just two lines overlapping, which means that they have infinitely many solutions because they enter. In C, okay, there's a few ways you can look at C, okay? I had one student in one of my classes today recognize that the second equation is only one step away from being in slope-intercept form. So let's take a look at this one. So we've got 10x plus y equals 10. What they did was they subtracted 10x from both sides, and they got y equals negative 10x plus 10. Now, compare this equation now to the original one on top. They have the exact same slope, but different y-intercepts. That means that they are parallel lines, and parallel lines have no solution in a system of equations. So therefore, there's no solution. Now, the other way you could do this is you could use substitution and plug in negative 10x plus 2 wherever you see y in the second equation, and you would get 10x plus, in parentheses, negative 10x plus 2 equals 10. This is using substitution. The 10x's will cancel, and you'll get 2 equals 10, which is not a true statement. This is also no solution. Okay? All right, and then let's see some examples of infinitely many solutions. So, for example A, okay, the best method in example A, from what I'm seeing, is to use elimination, okay? And the reason it's elimination is because all of the x terms are lined up, all of the y terms are lined up, and both of the numbers are lined up, okay? The equal sign is in the same spot. It's to the right of the x and the y, and to the left of the number, okay? So everything matches up. That's why elimination is the best. And also, you can just multiply this top equation by 2 in order to get some matches. So if we multiply by 2, we're going to get negative 4x plus 2y equals 6. And then on the bottom, we have negative 4x plus 2y equals 6. So these match up exactly. So what we're going to do is we're going to subtract these in order to eliminate. Negative 4x minus negative 4x will give me 0. 2y minus 2y will give me 0. So 0 plus 0 equals. And then 6 minus 6 will give me 0. So I have 0 plus 0, which is just 0, equals 0. And that is absolutely a true statement. So therefore, if it's a true statement at the end with no variables, it's infinitely many solutions. Now, before we even did the elimination, okay, let's backtrack a little bit to this step. Ooh, hold on. Oh, there we go. Let's backtrack to this step right here. So we got negative 4x plus 2y equals 6, and we got the exact same equation down below. If you ever are changing one of your equations and you get the exact same equation 2 times, you know automatically your answer is infinitely many solutions. The reason is because if we go back an infinitely many number of times. All right, let's take a look at B. In B, I would also say that B, the best method is to use elimination. So we're going to take this top equation, multiply it by 2. Once we multiply it by 2, we're going to get 2x plus 2y equals positive 6. And then on the bottom, we're going to get 2x plus 2y equals positive 6. These match exactly. We can stop right here and write that there are infinitely many solutions. Okay? Not only do they have the same slope, if we change this into slope-intercept form, but they will also have the exact same y-intercept. All right, and our last one is C. Same exact thing, same exact process. We're going to take that top equation, multiply it by 2, and we will see that this is going to be 6x minus 4y equals 16. The bottom equation is 6x minus 4y equals positive 16, and we've got two exactly the same equations, infinitely many solutions. Perfect. All right, and last but not least, our very, very awesome and super amazing word problem. Okay, so our word problem says the perimeter of the trapezoidal piece of land is 48 kilometers. The perimeter of the rectangular piece of land is 144 kilometers. Write and solve a system of linear equations to find the values of x and y, okay? So when we're thinking about perimeter, okay, I want you to think about the perimeter is adding up all the sides of the figure. So we need to find the length of all the sides. Well, the length of this side up here is 2x. Let's write down 2x. And perimeter, you add all of them up. So let's add to 2x. Let's add 4x. So plus 4x. Let's also add 6y. And then let's also add 6y again. Oops. So plus 6y plus 6y. Now, altogether, it said that the perimeter of the trapezoid needed to be 48. So we're going to set that equal to 48. All right. So we've got this. And then the second piece says the perimeter of the rectangular piece of land is 144 kilometers. So let's do the same thing, but for this one, we've got 9x on this side. We've got 9x over here, so 9x plus 9x plus 18y up above, and then plus another 18y down below. That makes up all four sides of my figure, and those should all add up to 144, the perimeter of the rectangle. All right, now let's go ahead and combine like terms to make this look a little bit cleaner. This is going to be 6x plus 12y equals 48. And this one down here will be 18x plus 36y equals 144. So we have two equations. Let's write them again over here, up and down, right above each other. 6x plus 12y equals 48. And the second one was 18x plus 36y equals 144. And now that we have this, all we need to do to solve these equations is take the top one, multiply it by 3, so that we get a match, because we're trying to match up 6 and 18. And what we're going to see is we're going to get 18x plus 36y equals 144. The bottom equation, we're going to get 18x plus 36y equals 144. Oh my gosh, we have the exact same equation. Now, if you remember, when the equations match up exactly, you have infinitely many solutions. Okay, so what that means is, that does not mean that we have infinitely many amounts of perimeter, okay? The perimeter of the trapezoid is fixed to 48 kilometers, okay? But what this is saying is there's infinitely many combinations of x and y that will satisfy both of these figures to having a perimeter of 48 and a perimeter of 144 for the bottom one, okay? And that is our lesson for today. Go ahead and get started on your homework, and I'll see you guys tomorrow.